Hello students, how are you all? Welcome back to Akshar ID Foundation classes. I am your chemistry faculty S. Mohan. Students, in the 7th class chemistry, we started the chapter chemical bonding, right? In that chemical bonding, we are completed synopsis 1, synopsis 2. Okay, so in that we discussed what is chemical bonding and why do the atoms combine and what are the factors, Lewis-Cossel theory, this all we discussed, right? Today we are going to discuss about the ionic bond. Okay, we are going to discuss about the ionic bond. So students, let us see what is ionic bond. Ionic bond can be defined as the bond formed by the complete transfer of one or more electrons from one element or one atom to other. Okay, generally this transfer of electrons takes place from metal to non-metal. Generally, this transfer from metal to non-metal, and whenever a metal gives an electron to the non-metal, then this metal possesses positive charge, right? And when the non-metal takes an electron, it possesses negative charge, right? So now here the bond is forming between whom? One is positively charged particle, ion, and second is negatively charged ion. So you can also define ionic bond as simply the bond formed by the bond formed between the two oppositely charged ions. Like this also you can say. Okay, so you can define in different ways. Okay, so the bond formed by the complete transfer of one or more electrons from one atom to other, the bond formed by the transfer of electrons from metal to non-metal, or the bond formed by the two oppositely charged ions is called the ionic bond. So three definitions I give. In that any one definition you can write. Okay, so here we discuss about the formation of ionic bond. Okay, so the first one simple definition I'll write. Okay, so that is the bond formed between two oppositely charged ions or a transfer of electrons. Anything? Okay, so I'll write the simple definition. I'll write the bond formed formed by the complete transfer of transfer of one or more electrons one atom to other. Okay, why I am writing the definition? Because I am going to explain some examples. Okay, so to understand this definition will be useful to us. Okay, so now students, let us see examples. Okay, what we can give an examples for the ionic bond. Ionic bond, so many examples we can give students, like sodium chloride NaCl. Okay, magnesium oxide MgO, and you can write potassium chloride, magnesium chloride, and so etc. So like this, so many examples we can give and examples for the ionic bond. So let us see how ionic bond is formed. So how ionic bond is formed? The bond formed with a complete transfer of one or more electrons, okay, from one atom to other atom, right? So now what we do? We take, now first let us see the formation of sodium chloride. So see students, here sodium chloride, the bond is forming between the sodium and the chlorine. So first we take the sodium. You know that sodium atomic number is 11, right? So what will write the electronic configuration? We can write the electronic configuration 281. In the previous class we discussed that the atoms which have octet configuration, okay, in their outermost shell, valence shell, they are stable, right? But here you see 2, 8, 1. So here one electron is there in the valence shell. So it is not stable, right? So to attain the stability, what it is to do? It has to lose that one electron. So here one electron is there. So that has to lose that one electron. So now what happens here? Here sodium, okay, sodium loses one electron. So it's losing one electron. When it loses one electron, so students, you know that it becomes a positively charged. What it becomes a positively charged. Is this clear? So this is the sodium. Right. Now it is combining with what? Chlorine. Right. So let's take the chlorine. Here I'll write the chlorine here. So chlorine, atomic number is 17. Electronic configuration is 2, 8, 7. Right. So here now see first shell 2, second shell 8, third shell is 7. Now say whether is it stable? No. Because according to octet rule, what? Last shell should have 8 electrons. But here how many electrons are there? Only 7. So it's not stable. So now it requires one more electron to attain the stability. Now what the electron, okay, is given by sodium, is lost by the sodium, that electron will be taken by the chlorine. Now see here, so this chlorine, okay, takes this one electron. So one electron. When it takes one electron, it becomes Cl negative. Cl minus chloride ions it becomes, right? So it becomes chloride ion. Clear? When it becomes chloride ion, now see here, it is Na plus, this is Cl minus. So this is cation, this is anion. You know that the opposite charges attracts. So there is a force of attraction between these Na plus, okay, and this minus Cl minus. So it forms NaCl. Okay. So now sodium chloride is formed. How this sodium chloride is formed? By transfer of this one electron. So by transfer of this one electron to chlorine. So when it's taking one electron, so now here what happens? The electronic configuration. See, now what is the Na plus electronic configuration? Na plus electronic configuration is just 2 and 8 because it lost one electron. So outermost shell, how many electrons are there? 8. So octet rule, it's stable. Now here you see what we write the electronic configuration of Cl minus also. So Cl minus electronic configuration is what? Okay, 2, 8, 7 was there, but you taken one electron. So now it becomes 8. So this also becomes stable. So both became stable and the bond is formed between them. Clear? This is the formation of ionic bond, and sodium chloride is a example for the ionic bond. Okay, students. So now, now we'll discuss about the structural also. Structure wise, how can we structure? So see here, sodium. So sodium, students, here you can see, observe carefully here, 2, 8, 1. So first let us take that this is a nucleus of the sodium and this is the K shell, this is the L shell, this is the M shell. Okay. So now how many electrons are there in the K shell? 2 electrons. First shell has 2 electrons. I'll put 2 dots here. Okay. 2 dots here. Second shell, how many? 8 electrons. So 1, 2, 3, 4, 5, 6, 7, 8 electrons. Now the last shell, 1 electron. Right? So this is the sodium structure, students. Right? Now it is combining with what? Chlorine. So it's combining chlorine structure also we write 2, 8, 7. So see here, this is the nucleus, this is the first shell, this is the second shell, this is the third shell, right? Same, third shell. Okay. Now here, it's looking little big, no? Okay, I'll small little, I'll rub. Okay, so now I'll take nucleus, first shell, second shell, third shell. Okay. Now how many electrons are there now here? 2, 8, 7. Okay, 2, 8, 7. So now see 2, 1, 2. Here 8, 1, 2, 3, 4, 5, 6, 7, 8. Here 7 are there. 1, 2, 3, 4, 5, 6, 7. Okay. So now this is unstable, this is unstable. Okay. Because here last shell only 1 electron is there. Here last shell 7 electrons are there. It should be octet, means 8 electrons should be there. So now what happens now? Here this 1 electron, sodium is losing 1 electron, chlorine is taking 1 electron. So what happens? This one electron get transferred here. Okay, so I'll represent it with the blue color. Okay, so this is the electron got transferred. Now how many electrons are there? 8 electrons are there. See here? 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons are there. Okay, stable. Now here when it is losing one electron, so you need not to draw this shell now. So now this becomes outermost shell. If this electron is losing, so now here how many electrons are there? 8 electrons are there. So now, okay, 8 electrons. So this also becomes stable. Clearer? So this is Na plus now. This is Cl minus. Okay, this is right. And according to electron dot structure, in one more way also we can represent how we can represent Cl, sodium. So sodium, so this is very important. This structure what I am going to explain, this is very important. Now sodium Na. Here how many electrons are there? 11. First shell 2, second shell 8, third shell 1. So you have to represent only valence shell. According to electron dot structure, we have to represent only valence shell electrons. So last shell, only one electron there. So we can represent like one cross. Like this we are putting one cross, means one electron. Now this is combining with the chlorine. So chlorine atomic number is 287. But we have to put only the last electrons only, not total 17. Last shell, 7 electrons are there. So I'll put a dot. Okay, 1, 2, 3, 4, 5, 6, 7. See, 7 electrons. Now this is sodium, this is chlorine. Now this both are combining. Okay, when they combine, then what happens? You see now, this sodium is giving one electron here. This electron goes here. When electron goes here, it becomes Na plus. So when it lost one electron, so outermost shell becomes 8 electrons. Okay, yeah. So this becomes stable. And here now, see, when it's coming, the one electron is gained by the chlorine. Chlorine becomes negative. Now, one electrons are there. 1, 2, 3, 4, 5, 6, 7. And this cross, this electron only, but to represent. Okay. So this is the electron dot structure of a formation of sodium chloride. So see how many different ways I explained you. Okay. So this all to understand better. Okay, so you are in 7th class. Actually, you know, this topic is there in the 10th class for your regular class. Okay, but as you are IIT, okay, you have to learn little forward. Okay, so you should be forward than the others, right? So now, so once again, see here, ionic bond, the bond formed by the completed transfer of one or more electrons from one atom to other atom is called ionic bond, or the bond formed by the between two oppositely charged atoms is called okay, ionic bond. So you see students here, the Na plus and Na negative, the opposite charges are there. So here the force of attraction is called electrostatic force of attraction. What type of attraction will be present here? Unlike charges attraction, that force of attraction is called electrostatic force of attraction. So that's what this ionic bond is also known as electrovalent bond. What it's called as an electrovalent bond. Okay, so this is a formation. Is this clear? Sodium 11, 281, chlorine 17, 287. This is unstable. This is unstable because they don't have the octet configuration. So to attain the octet configuration, so sodium loses one electron. That one electron is taken with the chlorine. So it loses one electron, it becomes positive charge. When taking one electron, chlorine becomes negative charge. And there will be a force of attraction between these two. Okay, combined, that forms the sodium chloride. That is the formation of ionic bond. Right? That's all. That's all about the ionic bond. So now you can practice two, three examples here. So many examples I have given here. So here you see this. These all are examples for the ionic bond. These all are examples of what? Ionic bond. So you can practice some examples, right? So can you practice? Acha, one more I'll explain in short, right? Then we go to some other one, right? Acha, I'll explain here only. In short, I'm going to explain. I'm not going to draw this all the structures and everything. In simple way, I'm going to explain you. Okay? So I'll explain you that magnesium oxide. I'll explain you, right? Magnesium oxide, how it forms. So see students, here magnesium atomic number is 12, right? So electronic configuration we have to write 282, correct? 282. Now here you see the chlorine. Oxide. Oxygen atomic number is 8. Here we write the electronic configuration is 2, 6. Okay. In the valence shell, the magnesium only electrons are there 2. It's not stable. And here electrons are there 6. This is also not stable. So now what happens here? Now here what happens? This magnesium loses 2 electrons. So magnesium loses 2 electrons to form Mg plus 2. Because it's 2 electrons it's losing, it attains a positive charge. So plus 2. Now here what happens? These 2 electrons are taken by the oxygen. So now what happens? This oxygen gains these 2 electrons. So 2 electrons, it becomes O minus 2. What it becomes? O minus 2. So this is positive charge, this is negative charge. So now what happens? These both will combine. Mg plus 2 plus O minus 2 gives rise to MgO, magnesium oxide. Clear? So now, can we represent this also like this? Yes, we can represent. So we can take here now magnesium. Here 282. How many electrons we should represent around it? Only 2 electrons which are present in the valence shell, last shell. Only 2 electrons. Okay. So I'll put 2 electrons here. So one, I'll put a cross. Anything you can put, but I'm putting just for your understanding, I'm putting the 2 cross. So 2 electrons are there. Now this is combining with oxygen, right? So oxygen. Oxygen atomic rate 2, 6. So how many electrons I should represent? How many dots shall I put around the oxygen? 6 only. Why? Because valence shell 6 electrons. No. So 1, 2, 3, 4, 5, 6. Okay. Now what happens? This sodium magnesium is losing 2 electrons. So 1 electron goes here, 1 electron goes here. Then what happens when it goes electrons? It becomes Mg plus 2. Okay. And then this becomes oxygen, 2 electrons gaining, so minus 2. How can I represent? 1, 2, 3, 4, 5, 6, and 2 electrons are coming here, so these 2 electrons. So now total 8 electrons, this also become octet, so this is tip. Clear, students? So this is the formation of ionic bond. Okay, and the potassium chloride, magnesium chloride, calcium oxide, calcium chloride. This also you can give an example: calcium oxide, calcium chloride, and this all you practice. Practice makes you perfect. Okay, so practice this all. Right? Chalo. Shall I go to the next topic now? I'll go to the next topic. That is what are the factors affecting the ionic bond? Okay. I need to rub this one. Okay, chalo, right. Now the next topic is factors affecting the ionic bond. Okay, so factors. So students, here factors affecting the ionic bond. What are the factors that affect the ionic bond? Means what? Here in the ionic bond, one atom is losing the electron. So when it loses electron, it becomes what? A positive charge, that's called cation. And second atom is gaining the electron, so it becomes negatively charged, means what? Anion. So factors affecting the ionic condition is nothing but factors affecting the formation of cation, factors affecting the formation of anion. If we discuss affecting factors of the formation of cation, formation of anion, those are the factors for the formation of ionic bond. Right? Chalo. So factors, first one is that formation of cation. For formation of cation. Cation means what? Positively charged ion. Right? And second one is what? Factors for factors for formation of anion. So these are the factors we are discussing about the formation of cation and formation of anion, and these combinedly are the factors for the formation of ionic bond. That's all, because ionic bond is formed between cation and anion. The first one is low ionization energy. The first one is low ionization energy, or we can say low ionization potential. Already we studied in the periodic properties, periodic classification. So already we studied the periodic properties, ionization energy. Ionization means energy means what? The energy required to remove the electron from the valence shell, outermost orbit of a gaseous neutral atom is called ionization energy. So just now we discussed, like sodium is losing 1 electron. So from the sodium, if I want to remove 1 electron, if I take the sodium atom, if I ask to the sodium, Sodium, sodium. Can you give one electron to me? Can the sodium gives? No. Yes. So here we need to apply some energy. That energy is called ionization energy. So the element which has low ionization energy, means less ionization energy, they can give the electrons easily, right? So which have low ionization energy, they can give the electrons easily. For example, if you say sodium. Okay, already we discussed in the ionization energy properties. As you are moving from left to right, ionization energy increases, and as you move from top to bottom in the periodic table, ionization energy decreases. So, for example, if you take the first group element, did you remember the first group element? Alkali metals except the hydrogen. What are there? Lithium, sodium, potassium, rubidium, cesium, francium. Okay, so these are the first group elements. Yes. Those are the first group elements. As we discussed that as you move from top to the bottom, ionization energy decreases. We discussed, right? So here means what? Here, okay, we take the lithium separately. So you see now. So as you are moving from top to bottom, ionization energy will be decreases. Correct? So the meaning is what? Here we require more energy in the sodium to remove the electron than the potassium, than the rubidium, than the cesium, than the francium. Means what? Which can lose electron very easily. Which can lose the electron very easily because ionization energy decreases. Ionization energy decreases. Okay. So decrease means what? Sodium has require more energy than the potassium. Potassium require more energy than the rubidium. So in this way, if we take these two atoms, so here potassium loses electron easily than the sodium. Potassium loses electron easily than the sodium. So therefore, potassium can lose electron very easily. Means potassium can form K plus easily than sodium plus. Okay, so therefore potassium has more ability to form the ionic bond than the sodium. Clear? So that is called low ionization potential, which requires less energy to remove the electron. That forms a cation easily. So that forms a ionic bond also easily. So therefore among this one, cesium is down now. So as you are moving from top to the bottom, ionization energy decreases, we said. So cesium can form easily the cation. Right? So that is the reason. Now second one, low charge on the ion. Okay. Second one is what? Low charge on ion. See students, here low charge on ion means what? Sodium if you take. So if you go to the left to right, sodium atomic number is 11. So we write the electronic configuration 281. So sodium has to lose only one electron. Sodium beside which element is there? Magnesium. In the previous slide, means in the previous, just before this, I rubbed the board, no, there I explained you. Magnesium, atom number 12, 282, means magnesium has to lose 2 electrons. Then what is there? Aluminum. Aluminum is what? 3. So 283. So it has to lose 3 electrons. So which one is easy to lose electron? Sodium can lose electron easily to form a cation because it has to lose only 1 electron, right? But to magnesium, it has to lose 2 electrons, so it will little difficultly it form the cation. And aluminum, so difficult because it has to lose 3 electrons, right? So therefore, here when sodium loses 1 electron easily, then it becomes Na plus and Na plus. Magnesium has 2 electrons, so magnesium to form the cation, it has to lose 2 electrons, And if you take the aluminum has to lose 3 electrons. So therefore, which can form easily? Sodium can form very easily than the magnesium, than the aluminum. So therefore, sodium can form very easily because low charge. The charge is less in the sodium than the magnesium, than the aluminum. So sodium can form the cation easily, right? Third factor is the large atomic size. That is what? A large atomic size. So see this student, this only discussed the group. Atomic size will be discussed. As you are moving from top to the bottom, atomic size will be increases. Why? Because due to the addition of one extra shell. For example, take the hydrogen, electronic configuration we write only one. Means what? It has only one K shell, right? Now when we write the lithium, okay, 3 atomic number. So we write what? Write it 2, 1. Means it has K shell, 2 electrons, L shell, 1 electron. Means 2 shells are there. Hydrogen had only 1 shell. So 1 and this is 2. So this is bigger. Right? When you come to the sodium, 281. So K shell, L shell, M shell. 3 shells are there. So the meaning is what? Still the size increases. So as you are moving from top to the bottom, atomic size is increasing due to the addition of 1 extra shell. As the atomic size increases, the distance from the nucleus and outermost shell increases. If the distance increases, the force of attraction decreases. So it is easy to remove the electron. So therefore, bigger atomic sizes can lose the electron easily than the smaller atomic sizes. Okay. So in this, which one is bigger? Cesium is bigger. Cesium can form the cation easily than the rubidium, than the potassium, than the sodium, and so on. So bigger atomic size. For example, cesium. So cesium is bigger, it can form cation easily than the rubidium, than the potassium, and so on. Clear? That is over this one. Now, last and final factor is inert gas configuration. Inert gas or noble gas configuration. So here you can see now cation with the inert gas configuration. Okay, so inert gas configuration. So see here now. Here sodium has to lose only 1 electron to attain the inert gas configuration of a neon. Correct? Because sodium atomic number is what? 11. Neon atomic number inert gas, nearest inert gas is what? Neon. Neon is what? 10. So 2, 8. 8 electrons are there. Neon. And sodium 2, 8, 1. So 1 electron. So sodium is very close to the nearest inert gas. Then come to the magnesium. Magnesium is little far. Okay. Neon after sodium after magnesium. Right. So here sodium can form the cation easily. Okay. So similarly, if you take 2 elements like calcium and zinc. Okay. Here I'll give the other examples like calcium and zinc. Calcium and zinc. So students, here calcium atomic number is 20, right? So what will be the electronic configuration? 2, 8, 8, 2. This is electronic configuration. Okay. Then zinc electronic configuration is atomic number is 30. Where are the electronic configuration? 2, 8, 18, 2. This is electronic configuration. Check that. 2 plus 8, 10, 10, 20, right? 2 plus 8, 10, 20, right? 30. Okay. So now calcium loses 2 electrons to attain the stability. When it loses these 2 electrons, so your outermost shell has how many electrons? 8. So by losing 2 electrons, it is attaining the electronic configuration of argon. It attaining the electronic configuration of what? Argon, which is an inert gas. Here the zinc 2, 8, 18, 2. This also has 2 electrons. When it loses the 2 electrons, does it attain the electronic configuration of any inert gas? No, it does not attain the inert gas configuration. So it can form Zn plus 2. It can form Zn plus 2 by losing the 2 electrons. Okay, it can form Zn plus 2, but it is not a inert gas configuration. So therefore, okay, the cation with inert gas configuration can form the cation easily. So these are the 4 factors, students, very important. Formation of cation, low ionization energy, low charge on the ion, large atomic size, cation with the inert gas configuration. Okay, so these are the factors affecting the formation of a cation. Right? Now, let's see the formation of anion. Okay, and I'm going to discuss about the anion. So here anion means what? Gaining of electron. Anion means what? Gaining of electron. So what should be the factors? Few factors are different. Okay. For example, high electron affinity. Okay, the first one is what? High electron affinity. Electron affinity also we discussed in the periodic property, students, once you check. Okay. Electron affinity means what? The amount of energy released when electron is added to the gaseous neutral atom in its ground state. Right? So here one electron is added. Right? So when it added, so the amount of energy is released. High electron affinity means what? Higher energy should be released. Already we discussed in the last, in the previous class, that atom with the lower energy, okay, will be stable. Okay, elements with lower energy, atoms lose the energy to attain the stability we discussed, right? So higher electron affinity, the elements which have higher electron affinity can lose, can gain the electrons easily. For example, if you take chlorine, bromine and iodine, chlorine, bromine and iodine. So chlorine can gain 1 electron to attain the stability, bromine also can gain 1 electron to attain the stability, iodine also gain 1 electron to attain the stability. But here which can form easily? Chlorine can form easily because it has a high electron affinity value. Clear? So the element with the higher electron affinity can form the anion easily. This one can gain the electron easily and become the anion. Now second one is what? Same, low charge on the ion. Low charge on ion means what? For example, if you see, for example, F fluorine, oxygen, nitrogen. For example, I am taking 3 elements here. Okay. So fluorine atomic number is 9, you know that. Okay. 9 means what? 2, 7, we write electronic configuration. Oxygen is 8, what we write? 2, 6. Nitrogen 7, 2, 5. So to attain the stability, 8 electrons should be there in outermost shell. But here how many are there? 7 is there. Means what requires only 1 electron. So it's easy to take the electron, 1 electron, right? So that fluorine can form anion very easily. Okay. So take 1 electron very easily. So this becomes a negatively charged. Anion is formed. But oxygen also can form an anion. But the thing is that oxygen has to take 2 electrons. How many electrons? 2 electrons. So if it takes 1 electron, it becomes negatively charged. See here, when it takes 1 electron, it becomes negatively charged. Now to attain stability, it has to take 1 more electron. So already this is negatively charged, and electron we are adding, electron is also negatively charged. So like charges repel, yes or no? So it will be difficult to take the next electron to the oxygen. First electron it can take easily, no issue. But for the second electron to take, here when take 1 electron, oxygen becomes negatively charged, no? But 1 more electron it has to take, already negative charge is there, 1 more negatively charged particle means what? There should be some little repulsion, like charges repel, repulsion force will be there. So due to that what happens, due to that what happens, so it will be take the electron but with a difficulty. So therefore, it has to take 2 electrons but very difficultly it forms. Similarly, nitro has to take 3 electrons, it's very, very difficult. Okay, so therefore, here it has only negative charge 1, negative charge 2, negative charge 3. So low charge on the ion. So fluorine can form very easily the anion than the oxygen than the nitrogen. So this is called low charge on ion. Next come to the third one. Third one is a smaller atomic size. Okay, smaller atomic size. So here the element which has a smaller atomic size can take the electron easily than the larger atomic size. Okay, why? If the atom is small, the distance from the nucleus and the valence shell, outermost shell is less. Distance is less. If the distance is less, the nucleus has a positive charge and this electron will be attracted easily because opposite charges attracts. So the nucleus attract the electron, right? So force of attraction will be more if the atomic size is small. If the atomic size is big, okay, nucleus here is here, valence shell is there. So here now this nucleus cannot attract that electron effectively. Why? Because it is very far. Yes or no? So smaller atomic size. So atoms with the smaller sizes can form anion easily than the bigger size. Like fluorine can form. Fluorine is smaller than the chlorine than the bromine. So therefore fluorine can form easily the anion than the chlorine than the bromine. Okay. So now last and final one is what? Anion with the inert gas. So same anion with inert gas can form, okay, nearest inert gas can form easily. For example, take the fluorine. Fluorine can form very easily the anion, means what, negatively charged ion. Why? Because the fluoride atomic number is what, 2, 7. So outermost shell has 7 electrons. It has to gain only 1 electron to attain the, if it take 1 electron, so 2 and this becomes 8, 2, 8. So that becomes what, inert gas configuration of neon. So now, so the element which is very close to the inert gas electronic configuration, they can form the anions easily. So students, so with this the factors affecting is completed. So here I discussed the formation of factors affecting the formation of cation, factors affecting the formation of anion. So here cation, anion, factors, if you club together, that makes the factors affecting the ionic bond. Okay. Now just once see, so 1 minute, just once look at the board and then I'll explain you the properties of the ionic bond. Okay. So right. Chalo. So with this is done. Now next is the properties. Okay. With the properties, then we complete this synopsis. Properties is very simple, students. Here ionic compounds properties. Okay. Properties, ionic compounds properties is ionic properties, ionic compounds are generally solid in state. Very simple, I'll explain it just as a here. Okay. Ionic compounds like what I've written, sodium chloride, magnesium oxide, magnesium chloride, calcium oxide, calcium chloride, all these are the ionic compounds. So generally ionic compounds are first one, solid in state. How they are? Solid. Okay. Why? If they ask you the solid, why? What do you write? Because the strong electrostatic force of attraction exists between the ions. So that's what they are solid. Okay. Second one is what? They are very hard. Okay. They are very hard because same reason, because the strong force of attraction is there. So that's what they are very hard to break. Third one is important, students. Here. Yeah, third one, when you see ionic compounds are soluble in polar solvents like water. Okay, like sodium chloride is there. Sodium chloride can dissolve, okay, in water, but sodium chloride cannot dissolve in non-polar solvents like kerosene. For example, take the kerosene. You know the kerosene? Okay, the kerosene and one beaker or one glass, and in one you take the water and take normally salt will be there in our house. The salt is nothing but a sodium chloride. So take the sodium chloride, means salt. Take 1 spoon of salt in the kerosene, add 1 spoon of salt in the water and stir it. Then what will observe? The salt will be dissolved in water but will not be dissolved in the kerosene. So that's the third property. So the third property is what? Ionic compounds are soluble in polar solvents like water, but they are insoluble in non-polar solvents like kerosene. Okay. Next, they are good actually. See, one more important thing is that they are good conductors in liquids, means the molten state or soluble state. So for example, take the sodium chloride. Okay, sodium chloride is solid, right? Now if you take that salt, it's a bad conductor. Okay, if you take in the solid state, it's a bad conductor. Why? Ions are closely packed with each other, so no free ions are there. So that's what it's a bad conductor. Okay, but if you take the water and add the salt and mix it, now you pass the electricity, it becomes good conductor. Why? When adding the water, it's soluble, means it dissolves and also dissociates. Means what? For example, sodium chloride, if you add in a water, it splits into Na plus and Cl minus. So now they are dissociated into ion. They present in the ionic form in the liquid state, means the solution state. Okay, so that's what these ions will be responsible for conducting the electricity. So they are bad conductors in their solid state, but they are good conductors in the soluble state or molten state. They are good conductors. Okay. And their density is high, already we discussed, because the solid, they are closely packed, the density is high. So that's all. So these are the okay. And ionic compounds, when they react, the reactions are very fast. For example, if you take the silver nitrate and sodium chloride, it forms a silver chloride and sodium nitrate. It's within fraction of seconds, so it's a fast reaction. Okay, so with this synopsis is done. So now Uh, let's go to the some questions, right? So questions you see here. Covalent bond is formed by, actually we didn't discuss here covalent bond in the last class we discussed, okay. Covalent bond is formed by how? By the sharing of electrons. Did you remember there I explained the hydrogen molecule, formation of hydrogen molecule, oxygen molecule, nitrogen molecule, the sharing of electrons. So the option is fourth option. Second one, magnesium atom obtains stability by losing of, okay. So by losing of electrons, but how many electrons? Magnesium atomic number is what? 282. So it loses 2 electrons. So option is 2 electrons, the page number 22, right. Third question, sodium ions attain the stability by loss of sodium 281. So it loses only 1 electron to attain the stability. So option is 3. Fourth one, sodium chloride is an example of, sodium chloride is an example of what? Ionic bond. So the option is 4. Which are the following examples of ionic bond? Calcium oxide, magnesium chloride, calcium chloride, all of these. Fourth option is the right answer. Ionic compounds are soluble in, just now I told you, ionic compounds are soluble in polar solvents but not in non-polar solvents, right? So the option is polar solvents 3. Ionic compounds possess high melting points, high boiling points. Yes, both 1 and 2, high melting and boiling points. Okay. In fused means what? Just now I told you, fused means what? On heating they become molten, fused or liquid state in the solution states. Ionic compounds are good conductors. They are what? Good conductors. So option is what? 8. Dash type of forces exist in the ionic compound. Just now I told you that electrostatic force of attraction. So the first option is the right answer. Electrons which lose electrons are called, generally losing electrons are metals, gaining electrons are non-metals, correct? Okay. So students, with this we stop, and remaining exercise you try it, very simple exercise, very easy exercise. First read the concept properly, read the material properly, try to understand and try to write the electronic configuration. In the just now we discussed about the electron dot structure, transfer of electrons, this all, okay. Practice well and answer the exercise, okay. So students, with this we stop, okay. Till next class, take care of yourself, bye.